Hey everyone, let's start this video with an example. Each year in June, 10% of the trees die out, and in December, the workers plant 100 new trees. At the end of December 2000, there are 1,200 trees in the plantation. Now, considering 2001 as the first year, find an expression in terms of n for the number of living trees at the end of December in the nth year. So the question wants to find an expression, so usually we will use something like fn, right, because it's in terms of n, or for the board ones, we use gn, alright? Now, since we've been talking about sequence and series, and we've been using un or sn, we can also use un here, though we are looking at the exact term at a particular n, right? We're not looking at a series, right? Because when the question does not want us to find, the summation of the number of living trees from, like, let's say n equals to 1 to n equals to 3, right? That's not what we want. And therefore, we're not looking at a series, but looking at a particular term. Therefore, we can use un. We can also use sn, but we must define it as a particular term, all right? So because of that, let's first define our term, right? So let un be the number. So we can use number short form as no dot of living trees at the end of, so basically just copy down the question, like, at the end of December in the nth year. All right, so basically what to mean that U1 will be the number of living trees at the end of the first year, which will be December 2001. U2 would then be the number of living trees at the end of December in 2002. All right, because we have U1 as 2001. All right. So let's look at the context of the question. So each year in June, approximately 10% of the trees die out. So therefore, how many trees are left alive? It will be 90%. 90% is basically 0.9. So this is a GP. However, in December, the workers plant 100 more trees, plus 100, which is an AP. That means, if you notice, we have a combination of both AP and GP, which is the main point of this video. We're going to explore contextual questions where we involve both AP and GP together and find a formula at the end. All right, so not to worry, right? Because there are two different progressions, one GP, one AP. Let's do some experimentation first. So we have U0, which you know, because U0 is basically December 2000. Therefore, we have 1,200 trees. Therefore, U0 equals to 1,200. U1, basically, we follow whatever the context say. So in June, 10% die out, 90% remaining. Therefore, we have 0.9 times 1,200. Then we add another 100 because in December, they plant 100 new trees. Now, U2, same thing, all right? 0.9, whatever happened in U1, right? So 0.9, 1,200 plus 100. And then in December 2002, they add another 100. Now we will simplify, all right? But not really add into entire values, but we make it such that we will find a pattern here. If you notice, we get sort of like a GP and an AP together, right? So if you notice, the term on the left is something like AR square, right? And then the term on the right, over here, you notice it's A plus AR, and then so on and so forth, correct? Now, if we continue this trend, you notice that if we do U3, you put 0.9, then 0.9 square, 1,200 plus 0.9, 100 plus 100 plus another 100 outside, because basically what I did was 90% of the trees die out. So, sorry, 10% of the trees die out, so 90% is whatever is remaining. So this is U2, right? This whole thing is U2. Then you add another 100. You notice that you'll get 0.9 cube of 1,200, and then you get a summation, right, of a geometric progression, right? Because you get 0.9 square times 100 plus 0.9 times 100 plus another 100. Okay, so you notice that, hey, on the left, right, it's basically a geometric progression where it's the term itself, and on the right, it's basically the sum of another geometric progression. All right, and therefore, what patterns can we draw? If you notice, the nth term right? So the n corresponds to the power, right, of the left term, right? The power of the term of the geometric progression, right? So on the left, we have AR power n, right? Notice this will be A, this is R, this is n, power n, right? So the power on the left term would correspond to the n. On the right though, you notice the number of terms would correspond to n as well. So you see three terms here, number 3. If you look at U2, 2 terms here, number 2. And therefore, continuing this trend, we know that, okay, we have A, which is 1200. We look at the left term first, right? We know that the power of the ratio corresponds to n, therefore we have n. Then on the right, we know that there will be n terms, and then it's a geometric progression, right? So geometric progression where A is 100, you notice A is 100, common ratio is 0.9. So then we use the summation of a geometric progression, which is given as A bracket 1 minus the ratio power number of terms, which is n, right? Corresponds to n over 1 minus 0.9. All right, so we have A as 100, so you can put in 100 here. Simply put, we have 1200 0.9n plus 1000 minus 1000 or 0.9, right, holding bracket n. Therefore, we simplify, right, to get 200 0.9 power n plus 1000. All right, and this is our expression for the number of living trees at the end of December in the nth year. All right, so there we have it, the combination of a AP and a GP. So the context of the question gave us a combination, but at the end, what you notice is always pattern seeking, right? You notice ultimately on the left side is the term, right? You notice AR squared basically corresponds to ARN. And then on the right, so on the left we have this, on the right you notice is basically another set of geometric progression. Let's say we have B as the first term plus BR plus BR squared. All right, again R differs, but in this case R is the same. All right, so you notice, all right, this is basically a summation, all right, of a GP. Then this is basically a summation. It's basically the term of a GP. All right, but nonetheless the method is this way. All right, just do some experimentation first and then notice the pattern. All right, and this is actually the standard. Right, usually it's left term, you get one general term of a GP and also the summation of a GP. All right, so there we have it, the combination type of questions in sequences and series.